you would say we have rejected the null hypothesis. If you want to be like, this very stuff is traditional. You have rejected the null. You've rejected the null hypothesis because you can't believe this. If you believe that, that means you're ignoring the fact this thing landed way over here. So we're rejecting that and we're believing this. So it appears that, put that in words, put that in words, it appears that,
brain injury lowers.
love it. It appears that acute brain injury lowers IQ. Boom! What type of error could we have made? We could have made a type 1, right? Because didn't our test come, we said something changed. Only way to be wrong is to be wrong about it changing, which would be a false positive of type 1. Is that fair? Believable, hopefully, ish. Believable. Go, Veronica.
Stuck on p equals 0 still.
Oh, it's not. So great contextual question. I'm going to come back over here. Do you see how when we reran it here, Veronica, it said p is 9e negative 4? That's 0.0009. I changed the sample size. I changed the sample size. It's smaller now. When ours, we say that again?
Which is close to 0.
Which is close to 0. And guess what? It's not actually 0 in that calculation. It's actually, it rounds to 0. It's probably 0.000. It's got more than 4 zeros with a number. It can't ever be 0 because there's always a bit of a tail that it's catching. So your TI will say it's 0 when it rounds to 0 to 4 decimal places.
Can you remind me what that means in the context of t-values?
So answer that question for Veronica. So when you get that p-value of 0, what does that mean again? Again, this is one of my favorite parts of the course, is making sure you guys walk out of here with an understanding of this. Danielle, go ahead.
Doesn't it set the scale to 0?
What scale? This 0 here? Oh, 2 different zeros. This 0 is just the center of the curve. That 0 is a percentage, 0%.
0.
So that's a 0% chance, if you
So
will.
that's still a probability.
It is. It's p-value is, I wish it was a big P, not a little p. It's a big P.
Okay.
It's the probability that your data, I'm going to start it for you, and you finish it, okay? I'm going to start the statement and you finish it. It's the probability that you got extremely low IQ data, comma, assuming that, what?
It's on that curve.
And what does on that curve mean? What does this curve mean about acute head trauma? McKinnon, go. That's this curve. What does this curve mean? That it doesn't lower. This is the IQ is not lowered by acute head trauma curve. This down here, wherever it is the IQ is lowered curve, yeah? So what the p-value tells you is how likely it's on this curve.
0%.
How likely your data came back on this curve. There's almost a 0% chance that your data agrees with that curve. Which makes it hard to believe, yes? It makes it hard to believe it's on this curve. It makes it easier to believe that it's on some other curve. Unless, of course, we screwed up. That's the type 1 error, yes. Oh, crap, the camera's pointing the wrong way. Oh, well, it's okay now. Freaking camera crew. Thank you for that question. Yes, it's going to sound like, it's going to sound redundant, but I'm going to keep saying it over and over again. I'm going to have other questions interpreting p-values, because if you guys can walk out of here knowing what a p-value is correctly, you can handle any test that comes your way. Tests are just the icing on the cake. Knowing what the results mean is the most important thing. Now, Di, your question finally, an hour and a half later, I apologize, but it's all in stride. Her question is, can we just make a confidence interval? Can we just make a confidence interval for this instead of setting up a hypothesis test? And the answer is yes, and I think I know why nobody does it. What you have to do is you have to look back at that idea of margin of error from a t-interval. If you remember what a t-interval looked like, it's x bar plus or minus t times s over root n. And what that does is it sets up a two-sided confidence interval with x bar in the middle, and your margin of error, this is the minus t s over root n, this is the positive t s over root n. Yes? So, can you make it so that it's one-sided? Of course you can. You totally can. What you have to do is take that 2.5% and that 2.5% and shove them all into one side. So in other words, this is 95% area right here, yes? You've got to take all that area and shove it to one side. So if you have a belief that IQ is lowered by acute head trauma, you're going to want to have an uppermost value of the head trauma IQs and say it's no higher than this number. So what you do is you'd say it's making it one-sided. You'd go like this and say there's my lowered IQs. Notice how it's a flip-flop of this curve up here? Because it corresponds to that curve. It's lower, it's on this side. So what you need to get is what's that number up there, the high point of the curve. And what you'd have to do is you'd have to go to one of those horrific t-tables and figure out what the multiplier is for 95% confidence on that t-table, based on a 61 sample size. So it's just a matter of going through the table and finding that multiplier. You use the exact same value. You use the same S that you got, the 9 point, whatever it was, 9.2, root 61, but you have to find that multiplier based on a one-sided interval. And that's where I don't like teaching it because A, nobody uses them, unfortunately. But B, it becomes too much of a pain in the butt to do that. But what you're going to discover when you do that, and if you want to go further, you can do it after class. I haven't run through it with you. What you're going to find is that value right there is this side of 100. 100 is going to be over here, which means 100 is out of the interval, which means your IQs are lower. 95% confidence your IQs are lower. Does that kind of make sense? Ish. So it really, the crux of the argument, Di, is getting that multiplier for that quantity down here. And I hate that being the crux of an argument, something looking up in a table. That shouldn't be the crux of the argument. The crux of the argument should be interpreting it when you're done. But most students get lost right there, and then they can't go any further. So if you want to go further, I'll be more than happy to approach you with you after class. It's just that nobody uses them, which is unfortunate. You're not going to use it. Nobody uses it except for one weird government website that was updated in like 1997 and hasn't been touched since. Hard to believe it of the government. Fair? So great question. Unfortunately, nobody uses it, so we're stuck with these hypothesis tests. No. I'm glad you did, because there is a way to do it. This, in my opinion, if I could teach you this instead of this, you'd understand it more quickly. It's just this sounds weird now because we've been spending so much time with this, but you could have this right out of week 3, week 4 of this course, and this would be but a distant memory. But I teach you what's relevant, so that's what's relevant. Fair? Good question. If you want to go further, let me know. We can figure the rest of it out. But for now, let's practice. I want you guys to practice these. Okay, now you see how the t-test kind of unfolds. You see where it is. You see how to run it. I got 2 data sets down here. Speeds on, I believe this was Archie Briggs Road. I believe. God, some of this data is kind of old, I forget. 2 data sets showing speed along a certain road. I became interested in this road, number 1, because I bike commute on it, number 1. And number 2, because the speed limit changed. More on that later. It's changing in fast 5. How many of you guys come up Archie Briggs when you come here in the morning? You didn't, yes. Did you notice the speed limit change over the past 3 years?